friends, in this video I am going to obtain the Fourier expansion for the function f of x equal to, and I am going to show that whether the function f of x is even or odd. Using that, it will help us to find the Fourier coefficients easily. Okay, here the interval is alpha to alpha plus 2l is equal to minus pi to plus pi. That implies alpha is equal to pi, and to get 2l I can write pi minus of minus pi, which is equal to 2 pi. Therefore l is equal to pi I am going to get. Okay, l equal to pi and alpha equal to also pi. Interval is this one. Now how to check even and odd function? Here let me consider this one as first function. Whenever it is defined in two ways, I have to consider f1 of x is equal to 1 plus 2x by pi, and f2 of second function I will consider it as 1 minus 2x divided by pi. Now in f1 of x I will replace x by minus x. Since the interval is minus pi to plus pi, to check even and odd, in first function I will replace x by minus x. Then I am going to get it as 1 plus 2 into minus x divided by pi. That is nothing but 1 minus 2x by pi, which is equivalent to second function f2 of x. Therefore I can write f of x is even function I can write. Okay, since it is even function, sum of the coefficients, Fourier coefficient, automatically it will become 0. How it becomes 0? Let me check here. Okay, first Fourier series is given by, let me write, Fourier series is given by f of x is equal to a0 divided by 2 plus summation n equal to 1 to infinity an into cos n pi x by l plus bn into sin n pi x by l. Okay, then l equal to pi I have to substitute. Then I will get the series for minus pi to plus pi. Now let me calculate a0 first. A0 equal to, it is defined to be 1 by l integration from alpha to alpha plus 2l. Okay, alpha to alpha plus 2l into f of x dx, which is equal to, I can write it as 1 by pi integration from minus pi to plus pi f of x into dx. And directly I can write this equal to, okay, this is equal to, I can write it as 2 times, correct? This, as f of x is even function, I can write it as 2 by pi integration from 0 to pi f of x dx I can write, correct? Since f of x is even function. And what about f of x between 0 to pi? Between 0 to pi, here for 0 to pi, the function is defined to be 1 minus 2x by pi. Therefore integration from 0 to pi 1 minus 2x by pi will become x minus 2 by pi constant, x square by 2, 2 cancels. This one upper limit is pi minus x equal to pi square divided by pi, and one of the pi will cancel, pi minus pi, automatically it will become 2 by pi into 0. Therefore a0 value is equal to 0 I am going to get. Like that, an I have to calculate now. Okay, to calculate an, formula is 1 by l integration from alpha to alpha plus 2l into f of x into cos n pi x by l into dx. Substitute l equal to pi, which is 1 by pi integration from minus pi to plus pi f of x into cos n l equal to pi, that is cos nx dx, and which is equal to, I can write it as 2 by pi again, 2 by pi integration from 0 to pi f of x into cos nx dx, or okay, since f of x into cos nx is even function, that's why I can write it as a 2 times integration from 0 to pi. This one I have to integrate. What is the defined f of x between 0 to pi? That I have to consider and I have to integrate. Therefore, an is equal to 2 by pi integration from 0 to pi f of x. My f of x is 1 minus 2x by pi into cos nx dx. This one I have to integrate. To integrate this, Bernoulli's rule I have to use. 2 by pi 1 minus 2x by pi as it is into integration of cos nx is sin nx divided by n minus differentiation of 1 minus, that is 0 minus 2 by pi into integration of sin nx by n, it will become minus cos nx divided by n square between the limits 0 to pi. And for 0 to pi, sin containing term sin n pi sin 0 will become 0, since sin n pi and sin 0 equal to 0. Okay, only for this term I have to substitute upper limit and lower limit. That will become 2 by pi again I will take outside, that will become 4 by pi square, 4 by pi square minus minus and minus 3 times into cos nx, and again n square also I will write outside 0 to pi. Substitute upper limit minus lower limit, minus 4 divided by n square pi square into upper limit cos n pi. Cos n pi is minus 1 raised to n minus 1. This is my an, or I can write an is equal to 4 times 1 minus minus 1 raised to n divided by n square pi square I can write. This is my an. Next Fourier coefficient is bn. Bn is given by 1 by L integration from alpha to alpha plus 2L into f of x sin n pi x by L into dx. Now L equal to pi I have to substitute 1 by pi integration from minus pi to plus pi, and f of x is even function into sin nx into dx. But f of x is even function, even into odd. Here f of x into sin nx is even odd function. Therefore, I can write it as 1 by pi into 0. Okay, which is equal to 0. That is bn value is 0. Now the Fourier series will become becomes f of x is equal to a naught divided by 2 plus summation n equal to 1 to infinity into an cos n pi x by L plus bn into sin n pi x by L. Here f of x is defined that 2 ways, and a naught value just now calculated 0, only an I have to substitute. Summation n equal to 1 to infinity, an is 4 times 1 minus into minus 1 raised to n divided by n square pi square into cos nx. This is my Fourier series required. Using this, deduction I have to do. For deduction, let me put x equal to 0 again. Okay, at x equal to 0, my f of 0, that is 1 plus 2 into 0 divided by pi, or 1 minus 2 into 0 divided by pi, both are one and the same, which is equal to 1 on left hand side. Right hand side it will become 4 by pi square common outside, summation n equal to 1 to infinity 1 minus 1 raised to n divided by n square cos 0. Shifting to the left hand side, that is 1 multiplying, that is pi square divided by 4 equal to summation n equal to 1 to infinity 1 minus of minus 1 raised to n divided by n square. Put n equal to 1, 2, 3 and so on, which will become 1 minus of minus 1 divided by 1 square plus 1 minus of plus 1 divided by 2 square plus 1 minus of minus 1 divided by 3 square plus 1 minus of plus 1 divided by 4 square plus so on. Therefore, it is pi square divided by 4 is equal to 1 plus 1, 2 divided by 1 square, plus this will become 0, this will become 2 divided by 3 square, plus this is 0 again, next 2 divided by 5 square plus so on. 2 is taken common and shifted to other side, it will become pi square divided by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. This is the required deductions. Like this, some more examples I am going to solve on even and odd functions in my next videos. Please subscribe the channel, don't forget to hit the bell icon and also share the video. Thank you friends.